Okay, in this video we're looking at the properties of shapes and specifically some of the properties that are to do with shapes, the medians, altitudes and perpendicular bisectors. So first of all, properties of shapes. With a triangle, we have the four types of triangles, and we use coordinate geometry as a proof of what kind of triangle it is. So for example, this triangle, we may be given the coordinates of A, B and C and asked what are the properties of this triangle. By looking at it visually, it's hard to tell if at B that's a right angle or not. And it's hard to tell if the length of BC and AC make it an isosceles triangle. So the first thing you should do is look at the lengths, using your formula for the lengths of the sides, the length of BC and the length of AC. And if those two, if the length of BC, the length of that equals the length of AC, you could say that therefore it is an isosceles triangle because two sides are the same length, isosceles triangle. You could also look at the gradients of the sides. So if you had the gradient of the side AB, you found that gradient, and you multiplied it by the gradient of the side BC. For example, if this gradient AB is positive, let's say it's 5, and the gradient of BC is negative 1 over 5. When you worked out the gradients, you multiplied these together, that's over 1, so that's negative 5 over 5, which equals negative 1. Multiplied together, they equal negative 1, so therefore angle ABC is 90 degrees, and the lines are perpendicular. Perpendicular means that they're at 90 degrees. Perpendicular, and therefore it's a, you could say it's a right-angled triangle. Triangle. Up here, we're saying that those two lines, the gradients, multiply to make negative 1, so therefore it's right-angled. Using that as a proof. Our other kinds of triangles that we can have, rub that out, whoops. Yeah. We can have an isosceles triangle, a right-angled triangle, an equilateral triangle. If we worked out that all the sides were the same length, we would say, therefore, this proves that it's equilateral triangle. Or, if all the sides are not the same length, we can say it's a scalene triangle. 3 different lengths for the sides. Those are some properties of our triangles. Okay? So we have isosceles, equilateral, scalene, and right-angled. You may be given 4 points and asked the properties of that quadrilateral. It may be that each length here in the first shape, each side length is the same, and so it may be a rhombus shape. You would note in a rhombus also that the diagonals, if you had the diagonals, they should be at right angles. So they would multiply together to make -1. In the parallelogram, the opposite sides are parallel. So the gradient, for example, of EF would equal the gradient of HG. Parallel sides would have the same gradients. With a trapezium, the trapezium, you would just have one set of parallel sides, so only IJ would have the same gradient as the gradient of LK for a trapezium. This is parallelogram. Parallelogram. So those are some of the properties of quadrilaterals. The side lengths, whether they're parallel, whether the diagonals are at right angles, whether these are perpendicular, the diagonals, or not, and whether all sides are the same length, two sides are the same length. Of course, in a parallelogram, you'd get the opposite sides also being the same length. So that's our shapes. Now, something special, particularly for triangles. For merit and excellence, you need to be able to use proper geometric vocabulary. And one word that's very important is a median. If you have a line drawn from a vertex, a corner, say from vertex C, and across to the other side to the midpoint, this is a median. Think of median in the middle of the road, median through the middle of data. This is a median from the vertex, the corner up here at C, to the midpoint of the opposite side. So it cuts the opposite side into two equal halves. That's a median. It may not necessarily be at right angles to the opposite side. And you can look at the properties of that line and what the length is, what the gradient is, what the equation is of that line. You've got the formulas for those, you've done that. The second line is an altitude. An altitude always goes up at right angles from the base. It's perpendicular to the opposite side. So it's from a vertex, it drops down, and it hits the baseline at right angles. So that's an altitude. So of course, if this was point B up there, that vertex is B, and it comes down to a point here, let's say point D. So the line BD, the gradient of BD times the gradient, if this was A here and point C there, of AC, if you multiplied the gradients, they would equal -1, and you would show that this is an altitude because it's at right angles. BD's at right angles to AC. Now, a perpendicular bisector is at right angles to the line. Perpendicular means it's at right angles, 90 degrees. So here you see a line, a black line that's at right angles to the green. It's a bisector, bi meaning two sections. It cuts it into two equal sections, so it's a bisector. It's at right angles and cuts the line in half. So that's why this line here would be called a perpendicular bisector. And of course, if you have an isosceles triangle, let's just draw one. Isosceles triangle. If you drew a line to from here straight down, it's in fact almost all three. It's a median because it cuts this in half. It's perpendicular and it is at right angles, perpendicular bisector. It's also an altitude because it is from the vertex and it's perpendicular. It's also a line of symmetry is one other kind of line. It's a line of symmetry. It's like a mirror line if the triangle is an isosceles triangle, cutting through the middle. These again are all properties of lines, and they are the proper names that you can call them. Okay, moving on. Let's do an example. If you are given, you may be given, for example, triangle ABC, and you're given 3 points. A equals 0, 8, B equals 12, negative 4, C equals negative 6, negative 22. And you're asked to investigate the properties of the triangle. So do a rough sketch of your triangle. If this was A, B and C. So you could find, now for achieve you really just need to find a midpoint and a gradient and answer a question. So you could find the midpoint of AB. So if A is 0, 8 and B is 12, negative 4, the midpoint of AB is going to be 0 plus 12 divided by 2, 8 plus negative 4 divided by 2 is going to give me 12 over 2, which is 6, 4 over 2, which is 2. So I have a midpoint here. Midpoint. I could find the gradients of the lines. So the gradients of AB is going to be y2 minus y1, negative 4 minus 8, over x2 over x1, which is 12 minus 0 equals negative 12 over 12. So the gradient of AB is negative 1. It's another property of it. And you can go ahead and find the gradients of all the lines. Are any of them perpendicular or parallel? And you can find the lengths of all the lines. Is it an isosceles triangle if 2 are the same, if 3 are the same? Is it scalene? If all of the lines are the same, equilateral, if the lines are all different, a scalene triangle. So for example, the length of AB, D equals the square root of, it would be 12 minus 0 squared plus negative 4, negative 8 squared equals the square root of 288, which equals 16.4 units, is how long the length of AB. And you just write it with a line over the top to show the length of AB. And then go on and find the length of BC and the length of AC. Okay, and then the gradients of each of those lines. So that's how you investigate the properties. Now sometimes you'll be given a midpoint and you want to know the properties of this line CM. So if you're looking at the line CM, you need to talk about the length of the line. You've got this point M and you've got this point C. So you've got x1, y1, x2, y2. Like you've done previously, find the length of the line, find the gradient of the line, find the equation of the line, and then look at line AB. Is it perpendicular? Is it a mirror line? Those kind of things. Is it an altitude? Is it a median? If it came to the midpoint, then yes, you could assume it would be a median. That's the kind of question. So I've included this week for you to look at some problems similar to this, and then at the end of the practice sheet there are 3 practice assessments. So have a look at those. I'll also do a video with the answers for those assessment questions, so you can check to see if you're on the right path there. And have a good week. Thank you.